Thank you. Hello, everyone. I'm Cassie Carpenter. I'm a fisheries ecologist at Eastern Illinois University. And I'm going to today be presenting actually work that one of our recent graduate students did. But first off, I'd like to acknowledge everybody that's helped out with this project. First and foremost, all the staff at the Center for Fisheries and Aquatic Sciences, Illinois Department of Natural Resources, Sport Fish Restoration for funding, and a special thanks to Dr. Sakaris for helping out Caleb with this project. And then I'd also like to thank the Fisheries Management section of AFS for providing me with a complimentary registration. So before I talk about Caleb's project, I just kind of want to go over some things that we've done at EIU as far as catfish research. My boss, Dr. Colombo, he did his dissertation at SIU on catfish in the Wabash River. And so when he came to Eastern, he kind of wanted to continue those investigations. So in 2010, a couple things happened. In Illinois, we implemented a long-term fish population monitoring program on all of our large rivers. And the Illinois Natural History Survey was largely responsible for getting that set up. This is really standard 60 hertz selector fishing at 60 sites. But as a lot of us know, 60 hertz isn't really great for picking up catfish a lot of the time. So for our first project, which was my thesis work, we decided to add some fixed sites and do some lower pole selector fishing and hoop netting and trot lining and whatnot. And with that effort, we did get a publication out in North American Journal of Fish Management. Moving on to 2012, we actually did a small project on flathead catfish movement with ultrasonic telemetry. And in 2013 is when we started building this data set that Caleb used for his research, and where we use a benthic electrified trawl to pick up young of year catfish. And moving on to 2014, we did some channel catfish movement work and channel and blue catfish gear assessment and demographics, where we also added 12 hertz selector fishing. Now more recently, we're still doing LTEF. The electrified trawl work is still going on. We did wrap up those blue and channel projects. In 2016, we actually incorporated some genetic analyses into our research. We got a publication out of that for channel catfish. And Alex did get a lot of his information from our trawling efforts. And that's kind of what I want to focus on today is our electrified trawl efforts that we did on the Wabash. And Caleb, so this is actually his presentation. I'll do my best to not butcher it. He was using this trawling information to estimate daily growth of these young of year fish. So for you that are not familiar with the Wabash River, it's a pretty unique system. It's the longest free-flowing river east of the Mississippi. And since it's unimpounded, this it makes a really unique research opportunity, obviously, by providing this really diverse habitat and therefore a pretty high fish diversity. And there's also a pretty good commercial fishery presence on the Wabash River. And one of the top commercial species are channel catfish. As we all know from this conference, they're a highly studied species, mainly with adults though, but the information on these age-0 fish is lacking. And channel catfish, their value as a fishery is pretty significant, especially on the Wabash. Recreationally, they're about 77% of the targeted fish, and commercially, 43%. In Illinois, they are the bulk of the exploited ictalurids. So therefore, because of their value, we really should try to broaden our understanding about them and with these young of year fish and answer some maybe of these early life history questions and help fill in these gaps in the literature that the adult research just doesn't quite get to. One of the big problems though, to collect these age-0 fish, you typically have to implement other gears, and their aging structures are very difficult to deal with. They're really hard to remove and difficult to process as well. So you're entailing a lot of extra labor and resources that a lot of us, unfortunately, just don't have the time to do. But luckily at the university, we have graduate students that can do that stuff. So Caleb, his three main objectives was to assess the impact of discharge on catch per unit effort. And then he wanted to examine size structure and age structure of these age-0 catfish, and then look at the growth patterns. So as I mentioned, the lower Wabash River is where we focused our study. There's 9 fixed sites that have pretty much stayed the same over the last 10 years with a few exceptions. Our northernmost site is in Hudsonville, and the southernmost is in New Haven, which is about 8 miles from the confluence of the Ohio River. So our field methods, I think, is what makes this, one of the things that makes this very interesting is we're using this novel gear that's a DC benthic trawl. And there's a video of Kelly and Sam deploying the trawl. One downfall of this, it's pretty limited by water level, which, as we know, a lot of gears are affected by that, but it's pretty significant with this one. I mean, it just doesn't work as well, and obviously it becomes dangerous at some point. So, and our actual efforts, so we went to these, 9 sites about a mile long, and we created 7 random points and picked out 3 of these points to pull a trawl for about 3 minutes in the downstream direction. I did want to show a diagram of this trawl. This is from Freeman et al. Looks like a pretty typical trawl, except for on the tow rope you have an insulated electrical cable that houses the anode and cathode lines. And also you have droppers on the tow rope. In this picture, ours are actually in the net though. And these metal otter boards are important because that insulated electrical line is anchored to these otter boards, and that's where the cathode and anode lines split, and to give power to the droppers and then to a chain in the foot rope. So for the lab methods, Caleb basically just stored fish on ice and froze them, and of course ID'd them and measured them back at the lab, and then he took a subset of these fish and removed the otoliths, which were transversely polished with lapping paper, and a photo was taken at 100% magnification. And I don't know if you guys can see on the slide here, probably not. These things are very tiny. They're about the size of a grain of sand, so it's pretty difficult. Here's a picture of the otolith after it has been processed. So pretty decent annuli visibility, but I mean, it's definitely not the best. But as far as his discharge data, he basically just mined the USGS historical data for the Mount Carmel gauging station. Mount Carmel is thought to kind of be a representation of the whole river. So his data analysis, he did 2-way ANOVA for the annual and monthly catch per unit effort and discharge. And then he did a Kolmogorov-Smirnov test between the length and age distributions between months, and regression paired with ANOVA for growth rate. So I'm going to start off with his assessment of discharge impact on catch per unit effort. Oh, some stuff didn't come up on my slide. Cool. Well, in 2015, he did not include that year in his analysis because we did have incredibly high water late into the sampling season, so there just quite wasn't enough samples to include in his analyses. But if we look at the other years, 2017 actually had a significantly higher discharge. And if we look at that a little bit closer as far as the average discharge across the sampling months, the other years follow this pretty standard pattern, high spring water, and then it gets lower as we go through the summer into the fall. Except for 2017, there was a peak in discharge in May. Now, if we look at our monthly mean catch per unit effort, all the years follow this pretty similar pattern that we would think of with catfish spawn. starting off slow in May and then picks up and hits about a peak in August and then drops significantly as come into September. So, but the real question is, did discharge affect overall catch per unit effort across the years? And it appeared it did not. So, long story short, it seems that they'd have pretty stable spawn success regardless of some of these high flood pulses. So now I'm going to move on to examining the size and age structure that he came up with. So in June, I'm sorry, some of the stuff is not showing up on these slides. I don't know why. In June, we have we didn't catch very many fish. We're supposed to have the number up there. And they were pretty small. The arrow represents the average size of a fish collected. And then moving on to July, we started to catch more fish, and the average size fish collected went up as well. And then in August, this was our peak catch, if you remember, but the average size went up a little bit as well. And then in September, our catch dropped significantly, and the average age jumped quite a bit. Now, this is our age distributions. For July, the average age is about 25 days, by the way. In August, it jumped up a little bit to 27, but we're still getting some of these younger fish, so this is signaling the cohort overlap. And then September, the age climbs up again, and we're starting to see the disappearance of some of these younger fish, which is supporting that the spawn is probably about complete by then. So now to look at the growth patterns exhibited by these fish. Yeah, there's like a lot missing down at the bottom. Well, he had hatch week. It was June and July and August. And basically what this is showing as fish that hatch later in the year, they're growing faster. And then when we look at each month and fish grow through each month, there's this trend as they get older, growth slows down, which makes sense. And we're seeing it in July as well, and then August. So overall, what did he get out of this? The larval mortality rate is really high, which we see that with a lot of freshwater fish. And there is some growth variation in cohorts, and there's this probably selection for faster growth, which makes sense because obviously you'd want to get probably as big as possible before winter comes to ensure survival. And then for his age and size structure, he saw these repeated ages, so this is supporting that they are a prolific serial spawner. And the lower proportion of smaller, younger fish in September signals that there's probably, after July is when the spawn begins to end. And so the effect of discharge on catch per unit effort seem to be pretty minimal, so they have a pretty stable spawn success. And there's a similar monthly trend in catch per unit effort that illustrates the spawning period pretty well. There was a flood pulse in July that may have caused a short-term pause for the spawning, and then maybe once the water level stabilized, they was a signal to continue spawning, and it caused a higher catch per unit effort later in the summer. Oops, I didn't mean to go back that far. Well, so basically what we want to do moving forward is we want to continue investigating these impacts of flood pulses on spawn success of these channel cats. And then we want to try to look at some annual similarities and maybe tease out some other factors that may affect their successful spawn. And we really would like to look closer at the winter and see what abiotic factors may influence winter survival as well. And ultimately, we would like to determine these strong year classes and to kind of get an idea of what recruitment is happening and what could affect recruitment. And we are getting ready to do another adult assessment on the Wabash, and I think this will kind of help us get back at that question. And we did have some regulation changes, so I think this adult assessment will be important for that. I will do my best to answer questions. I have Caleb's email up here. He would probably be able to answer things in a little bit more detail, but that's all I got. So if you got any questions, let me know.
Questions?
Okay, that's his email, if you think of something.
Thanks.